I'm going to show you how to upload a model to Shaderhub from Blender using this plugin I've just created. So at the moment this is fairly low res model, but you can sort of fool the shader into thinking it's higher res by using this multi-res tool and then baking out some textures. In particular, the normal map describes the curvature along the surface, and you can sort of put bumps and sort of fake it. So I put this kind of bumpy texture on, and then but the edges are still going to look low res, but you can sort of make the texture, at least across the surface, look as if it's smooth. So if you look here, I've got these textures, and this normal map here, if I just zoom in a bit, you can see that it's got these various kind of degrees of shading here across it, from kind of blue to red to green, and basically it uses the red, green and blue color channels to describe the direction of a normal, and so the direction of the normal dictates how the surface gets shaded as it's rendered. And here we've also got an ambient occlusion map, which is a kind of self-illuminating technique. And then this is just the standard texture map, so this is just the general colour. I think I just generated that using a couple of Blender tools to do procedural Veroni or noise texturing, and just kind of added a few textures together and got this kind of slightly sort of marbly type skin effect. This kind of, I suppose it looks more like marble than skin, but I was just playing around. So that's for the dragon skin. I haven't done any definition for eyes or teeth or any kind of detailed texture mapping. If you want to do that, you can do that. I might do it at some stage. I mean, basically the idea is you'd have to slice the mesh up into parts that you want. So I go into edit mode and mesh. You've got this, you can sort of mark edges, mark seam here, and so what you do is you select a load of edges and you mark seams where you want them, and it will chop the 3D into texture, a bit like how seams work on cloth. When you've got some trousers, you can have to put a seam somewhere if you want to take them and unwrap them from the 3D trousers onto a 2D flat piece of cloth, right? So it's basically the same principle they use for texture mapping. So back to this. So there's our mesh. Normally the first thing it does is it sort of turns it into triangles, because it's all quads here. Quads are kind of nice for modelling, but when it's rendering, it prefers to just use triangles, or just assume everything's triangles rather than have different numbers of degrees. I mean, you could improve your shader code, but at the moment everything's just an array of vertices and they're all triangles, and it's all kind of fairly simple. No indexing or anything. So this is the mesh. So the new plugin, if you've installed it, should be in this section here, the third one along, called Shaderhub. So the scene section, and there's this kind of a few things to fill in, and those basically mirror what we had to fill in before. If I go to the home page, I said if you do it with the script, that you need to kind of fill in these fields, which are the file name, a description, and a secret code, and then the mode that you want to use. So in this case we use overwrite most of the time. I mean, I've also got another one called merge, which is, the idea is that you can add partial things, bits of data to your original data without affecting the original file if you use the merge option. For the most part you'll be using the overwrite anyway. So now I've replaced the script with this plugin, and once you've sort of downloaded and copied it in the right place, so there's another tutorial on that it should be in this list here. And there it is. And so you just got to make sure that's switched on, and once that's switched on, and exists, you can access it here. So we'll give it a file name. Okay, then now what we need is this secret number. So I'm logged in to my profile. I've got the secret number here. And I'll just plonk it in there. I think I might have got one too many characters at the beginning. No, that's okay. And I want mode overwrite, and if I hit upload, not sure it's actually done anything there. Here we are. It should now upload that model to the website. Group files. There we go, Dragon. So that's our file. And here's our data. So you can sort of view the data here. So there's quite a lot of numbers and stuff, and this is the actual data that's being sent up. And what I want to do is go to the configure section, because as you can see there's these bits of data, but the shader still doesn't know about the data. So in fact we need a texture as well. So this one, the default shaders just use a single texture, so I'm not going to go into the normal mapping or anything too complicated. I'm just going to use the basic shader that gets sent up as the initial phase. I mean, you can modify it later. And we'll use this texture here. So first thing is to upload that texture. Find it. Kind of messy here, you can see I've got lots of junk. Dragon text.png. These should be powers of 2 square. So it's got to be either 256 by 256, 512 by 512, or in this case I think it's 1024 by 1024. Unfortunately it refreshes on the wrong page, but you can see it's loaded up there on the wrong tab. It forgets, when it refreshes the page it doesn't automatically jump to the texture tab. I need to tidy that up a bit. So go to configure, add a program. So I picked the shader. So this is so it's called cube, even though it's not a cube. I probably didn't rename it to Dragon. If you look in here, it's just called cube. And there's the frag shader. And those are the default ones that can come with it. So I can pile those up. Then I pick the normals and the vertices, and here it's asking for the UV coordinates. So this is basically how you go about configuring any kind of simple textured object to get started. So here we need a projection. This define here allows you to type in manually any matrix you want to pass in, because if you think about these values here, these are essentially the uniforms in the shader. So what goes in is it depends on the type here. So these are vec3s. I've got a sampler here. I've got some matrices here. Right, got a vec2 there for. I know that's a varying. Sorry. And these ones here basically reflect the attributes. So what we're doing is we're telling these shaders what data to connect, to pass to the shaders, and the data's been uploaded, or most of it has. So certain things you define yourself because there's some built-in operations, and that's where I've got the supply operations thing here. So rather than sort of having to type in your own projection matrix, it's much easier to use the operation. So here I've got the projection matrix that needs to go into this matrix here. So if I type projection, and I can choose between perspective or orthographic, and we're going to use perspective and apply. Here, this is the normal map, so I'm going to get the world, apply inverse and transpose, and that's I think you're supposed to calculate the normal map from the matrix, what you use the thing that's applied to the vertex normals to move them with the scene, I believe. So point lighting color. So we have, this wasn't sent up. So point light color. So I'm just going to call this light color, and I'll give it a default value of just white, which is all ones. These are your red, green, blue channels, right? Apply. Then what I'm going to do is going to add a slider. So this allows us to change it on the user interface, so we can change the colors. And so the range for each of those sliders is between 0 and 1, and the step is 0.1. Okay. So that's that one. We've got this model view matrix. So start with the world. That's our model matrix, but we also need to multiply it by the view. So what we do is apply the operations here, and I've got this one called camera look at, and this basically uses some camera parameters to calculate a view matrix. So we add that in, apply. Then I've got some point light location. So here I'm going to define it and just put it at, say, I think minus on the Z is towards us. Actually it uses minus in the Y because Blender has Z upwards, I think. But, I can't remember how it's configured. But anyway, so that's point lighting. Obviously there's, you've got left and right-handed as well, so minus is sometimes towards you and sometimes away from you, and these things are not completely standardized, so unfortunately you have to think about where things are. So here I'm going to add another range slider, and I'm going to put a bigger range, say from minus 100 say to 100, and a step of 0.1 should be fine. Probably even 1 would be okay, because it's maybe 0.1 because it might not be very smooth. So that will allow us to move our light source around the scene. The next thing I'm going to do is choose an ambient color. We haven't got one. If we sent up colors, it would be in there. So we have to define our ambient color. Again, I'm going to choose white. We can always play with that on the UI, but black is probably not such a good idea because you might not see something if you put things as black. So I just usually put everything in white and then allow the user to change them on the front end. But you can set them up with what you want, really. So this is in the range of 0 to 1, so we don't have to change those. Next I pick my sampler, so here I've got that texture, and that's the name of the texture that I just added up. And then I'll commit the bindings. Okay, and then if I go to render, you can see we've got the dragon up there, and so he's not spinning around or doing anything because I haven't put anything like that in the shader. In fact, it looks like, are we looking from behind or the front? No, it could be the front. It's just the shadings it's quite pale looking. Maybe if I turn the ambient shading down, you see it will rely more on the light, the shading caused by the light, and you can see it's there. It's quite clunky looking because we haven't done any tricks with the smooth shading, so it's quite low res looking. You can move the camera around, however, so you can zoom here, and if you sort of think about the camera, basically what's happening is there's a point at where you're looking from and there's a point where you're looking to, and so if you move one of those, you can so here I'm changing where I'm looking from. This is the center is where I'm looking at, I think. Yeah, so that's the kind of point I'm trying to focus at, and then this is where I am in relation to the object. So here, if I move the X, you can see it's like as if I'm on the left side, and then I'm coming towards him, and then I'm going to the right hand side of him as I'm getting further away from him. And so that's the this is the height, because Blender, like I said, uses the Z in the sorry, this is like the Z in a way, because Blender uses the Y and Z the other way around. Unfortunately, it's a bit mostly in when you're doing computer graphics, you usually think about Z as being far away rather than up high, but Blender uses height as your Z coordinate, so it's more like the engineering drawing. So you can see that's rendered with this texture here. We've got things like field of view. You change the aspect ratio. I mean, this is set up according to the size of this window, so that it's basically the width divided by the height or whatever. But you can change that if you want. So if you've got like a narrow window or a bigger window. These are basically just things that the perspective projection uses to work out how to map the 2D onto 3D. Sorry, 3D onto 2D. It's a 2D screen, but it's a 3D object, so this kind of makes things get smaller as they get further away and so on. And we've got these clipping planes here, so this is the near clipping plane. You can see if I move it, it chops the object up as it gets to. It's got to be at least over 0, I think. Otherwise it's sort of, I think it gets singularity or something, it doesn't work. And then you've got the far plane, and that's kind of how far things go before. So this is if you chop the back. See it's chopping into the back there, or if I put it sort of here and then move the object. I'm doing that. But anyway, you can see that as it gets further away, it sort of gets chopped as it comes up. And we've got the lighting location here, so you can move the light around. And the light colour. Make it sort of a bit more red than like the dragon would be, I guess. Although probably would do the colour of the object in the ambient, and then use the lighting for the colour and the light, because the light would apply to all objects, not just the object that you're considering. So we could have a kind of blue light if we wanted, with a red. So there we are. That's the getting started tutorials. If you want to go further, you can experiment here, changing the shaders and compiling them here. One limitation is you can't add new uniforms or attributes here, because these need to be configured in that configuration stage. So if you're going to change those, you need to configure again with your change shader. But you can edit these shaders, and at the configuration stage, you just cut and paste your own code into there, and that will allow you to kind of improve them. Such as I'll probably do with this, to improve the shading to make it look like it's smoother, using the normal maps and the stuff I showed you earlier. So yeah, you can, or like for instance, if you want the object to spin around, you can put transforms in here, and then you can bind parameters like sliders on here to those particular attributes coming in here. So if it's just a floating uniform, which is just a floating point number, for instance, you can have a slider that moves that floating point number. I've also added a couple of other ones like time, which is just a kind of a constant time measurement every frame. It tells you the time, so you can use that for animation. So if you want to something to change every frame, you can use that and multiply it by your whatever your other factors are. Or you could, say you wanted to do an animated texture or some kind of thing like that, you could use the time variable. It just gives you access to something that's changing on a frame by frame basis. And so this is the basic shader setup. That you can do more with it if you're willing to experiment with the shader code and so on. Right, so that's it. Thanks very much. I hope you guys can figure it out. I was really pleased here. I looked at this list one morning, from having no users and thinking no one would ever use it. I had this nice list here of people that have signed up. But I realised that most of them probably were stuck trying to set things up, because they weren't sort of, maybe the instructions weren't clear enough about how to set things up, and hence this video. But I really hope to see people getting stuff up and figuring out. I hope that tutorial was enough to get you started. Yeah, see you next time. Cheers. Now I need to find the off button. Oh, there we are.